Hey folks, Mr. Hartzler here, and I want to talk to you about linear and quadratic systems. So it's both lines, linear, and quadratic or parabolas, and they're going to be systems. So I'm going to have both of them combined together. And let's see what that looks like after we check out our target. So our target, our goal for this video is that you can solve linear and quadratic systems and you can determine the number of solutions that are possible. So how many solutions can there be for a linear quadratic system? Well, let's just think about lines and quadratics together, right? So here, let's say there's a parabola over here. I'll erase the coordinate grid because that part doesn't really matter. And let's put a line here. How many times do these two things cross? 0. So that means 0 solutions. But that could be different, right? So what if I had, let's put a parabola here, and let's have a line go right there. How many solutions? 2. 1 here and 1 here. 2 solutions. But there's a case where I can get in between. Can I get just one solution? Well, here again is a parabola, and let's have a line come through and I'm just going to put a dot there, okay, because I didn't. That's the end of detention right there. So I'm going to have these two come together, and let's say I touch just exactly at one spot. That would mean one solution. So those are the types of solutions we could have, the number of solutions. I could have between 0 and 2. 0, 1, or 2 solutions for a linear and quadratic system. Let's go check out an example. All right, so now we need to determine the number of real solutions of the system. I've got a quadratic on top, I got a line on the bottom. So I'm going to use blue for this one. And we're going to roughly draw in what this looks like. So I need a couple of points here.
1, 2, 3, 1, 2, 3.
This quadratic here, I am not shifted left or right, so my vertex is at the origin. And then I go up 3 and over 1. We're very steep. And then, of course, the same on the other side. So I have a very steep parabola right there. Then we need to go in and we need to start looking at the other one. Let's use pumpkin spice color for that one. So I'm shifted down 2, and then it's a 3 over 1 for my slope. So I go down 2, and then I go up 3 over 1, up 3 over 1. Maybe they never cross each other. But let's determine that by going through this system and seeing what we can come up with. I am going to, my lights turned off on me. I've been sitting still too long. So I am going to set, they're actually both already set equal to y. So let us set them equal to each other. I'm going to substitute in. I'm going to use substitution. And I'm going to set these two things equal to each other using this. So I'm going to take this top piece, I'm going to substitute it in for that. So 3x squared equals 3x minus 2. Now I need to solve this, right? So we're going to, again, use the zero product property to tell me that I need to get all of this set equal to 0 so I can factor it or use quadratic formula. I'm going to subtract the 3x. I'm going to add the 2 over. Subtract the 3x and add the 2 over. All right, so now I'm here. Now I'm going to use the quadratic formula because that's the easiest way to do this, right? Okay, so quadratic formula says negative b plus or minus b squared minus 4ac all over 2a. All right, let's substitute stuff in and see what we get. All right, now I need to do some simplification. Ugh, this one's going to be kind of muddy, I think. Look at this again. Right here. My discriminant is going to be negative. It means there's no real solutions. If I don't have any real solutions, that must mean that we were right with drawing our graph. They don't intersect. So there are no real solutions to this one. I don't even have to go any further. I can just look at that discriminant and say 9 minus 24, negative number. Square root of a negative number is going to have an I in it. If I have an I in it, it's imaginary and it's not real. All right, folks, let's go on and check our next one. All right, now we're on this one. We're going to solve a linear equation, a linear quadratic system using substitution again. So let's see what we can do here. All right. Let us look at this first one. Oh, it's already y equals stuff. Well, that's nice. They set it up to be substitution. So I'm going to take all of this, and I'm going to plug it right into there. Let us start with this. All right, so now I plugged in all that blue stuff, and I just left the 3 blue. Whatever. Now, be careful here. A lot of you are going to mess this up. This negative needs to be distributed into everything here. If it were a plus, it wouldn't be a big deal because distributing a plus doesn't change anything. but distributing a negative does. All right, so now we're here. And now I'm going to have to combine like terms is my best guess. All right, so I did a couple things there, right? I combined my like terms. The 2x and the negative 3x gets me negative x. I had a 5 on the left and I had a 3 on the right. So I subtracted the 3 over. So now it's a 0 on the right side. And I have 5 minus 3 gets me 2 on the left side. Now I need to do some simplification here. Well, actually, instead of simplification, I need to do the quadratic formula, right? That's how I can solve for x now. This looks just like all my other ones. So let's write down the quadratic formula again, and then we'll plug in. All right, now I've plugged everything in. Be mindful and be careful with this. A lot of people mess this up when they do the simplification. But now I need to go through and just simplify this a little bit. I'm going to look at this 1 here. Double negatives. Okay, all right. Notice over here inside, negative 4 times a negative 3 is going to be a positive number. And then it's a positive 2, so we stay positive. So on the outside, I still have a positive 1. And it's up to you. I mean, you don't have to write that plus there. Me personally, I like to write it because then it reminds me that I knew I changed something. I did that intentionally. It is a positive, and it could be nothing else. So then plus or minus, and then square root of a bunch of stuff here, right? Still negative 1 squared, which gets me a positive 1. And then plus 4 times 3 is 12, times 2 is 24. All over 2 times negative 3, which is negative 6. Okay, so let's keep going. X equals 1 plus or minus square root of 25 over 6. Well, I know what the square root of 25 is, and I think a lot of you do too. So it's x equals 1 plus or minus 5 over 6. Now, it looks nice and pretty. Good. That means I need to go through and find each of these pieces. I need to split this up into the 2 cases. And I'll do that right here underneath it. X equals 1 plus 5 over 6. Well, that's x equals 6 over 6, which equals 1. I also have the case x equals 1 minus 5 over 6. And that's x equals negative 4 over 6, which simplifies to negative 2/3. So I have this one here. And I have this one here. And done! Not so much. Got to be careful. This says to solve the system. I need an x coordinate and a y coordinate. And actually, I'm going to have 2 because I have 2 x's. I'm going to erase the left side of my screen. So if you don't want to, if you want that, then you should write it down or freeze my frame now. Ready? Go. All right. So I erased all that. Hopefully you got it. If not, go backwards. It's a YouTube video. Now I have x equals 1, and I also have x equals negative 2/3. Those are my 2 x's. They're going to give me, each of them are going to give me 1 y value. I need to find out what that y value is, and I'm going to use this bottom equation because obviously it's simpler. So 2 times 1 minus y equals 3, and I'm going to solve for y now. So I'm going to subtract this 2 over. Negative y equals 1. Well, that means y equals negative 1. That came from which x value? From x equal 1? Okay, so 1 gave me a negative 1. I plugged in a 1, I got out a negative 1. Now, let's plug in the other part. I plug in a 2/3, so 2 times negative 2/3 minus y equals 3. 2 times that, well, that's a little bit more ugly, right? Negative 4/3 minus y equals 3. I'm going to add my 4/3. So negative y equals 3 or 4 1/3, right? 4 1/3. I could also, the 3, get a common denominator there, and that's going to be, well, times 3, so that's 9/3. So it gets me then, if I want to be fancy, 13/3, right? Yeah. So negative y equals 13/3. But again, it's a negative y, so it's got to switch. So negative 13/3 or negative 4 1/3. I kind of snuck it in there. But that coordinate point, well, it'll be all the way down at the bottom. But I plugged in a negative 2/3, and I got out a negative 13/3. Those are my 2 answers. I'll circle them in red so you can see them a little bit better there, because I get it. It is a little bit tricky to see. Sometimes it doesn't pop up right away. There we go. There's one. And here's my other one. All right, folks, let's go on to the next example. Alrighty, I know, it's words, but it's okay. Alex kicks a ball up a hill for his dog, Xena, to chase it. The hit is modeled, and I didn't spell modeled right either. The hit is modeled by a line through the origin. The path of the ball is modeled by the quadratic equation below, so you can see that there. How far does the ball travel horizontally? How far must Xena run up the hill to catch it? Well, let's do just a quick, real rough sketch of this, all right? So, I've got this function here. Oof. All right, here's your graph. Roughly, very, very roughly, but it's here. You hit here, and you actually both hit here at the 0, because that's where you kicked the ball, right? You started there. So did the ball, so did the hill. All right, because this line here, that's the hill, you know, up the nice mountain. Okay, that's the hill. It looks like a mountain. Snow Peaks right up here. Cool. And then that is the arc of the ball right there. So, how far did it move linearly? So what is really, they're asking what's the x-coordinate there. And then how far must Xena run up the hill to catch it? So up the hill is actually this number here. I'm going to write an L. That distance, let me change my color too. This distance here, that is how far the little doggy actually ran, is across the hill this way. So that might get some of you. Some of you might just put the y coordinate. It is not that. It is actually the slant. So let us go through now and let us figure out where these two graphs intersect. And to do that, I'm actually going to do substitution again, just like the last one. So I could use elimination, but substitution is going to be easier here because, again, y is equal to our stuff. Both of them weren't like that last time, but they both are this time. So I'm going to substitute this in for my y up here. I'm going to substitute my second equation into my first. All right, so now that I have them substituted in, I'm actually going to get everything over to the right side because that's where most of my stuff is now. Okay, now I can combine like terms. Both of these have some x's, so let's combine them. Okay, and there is again plus 0. Actually, not again. It's for the first time. Plus 0. That means that there's no other piece being added to it. There's no c value. Well, actually, there's still a c value, but it's 0. And that's okay, but I'm going to substitute that in when we get there, which is actually now. So I'm going to take all of that and plug it into my quadratic formula again. So x equals, you know what, I'm going to write it down because it's always easier to start off with the formula. Now I'm going to substitute it all in. Alrighty, let's go from here. And, oh, this is a little bit ugly, right? But, ooh, look at here. Let me change colors to red so you can see this real nice and easy. You see how my c value is 0? Well, what's 0 times anything, folks? Yeah, 0. So that means I don't have to do this part because it's 0. Sweet. So now I just need to do 5.5 times 5.5. All right, I'm going to do that off to the side. 3025. Cool. I'm going to take that number and I'm going to put it in there. Oh, wait. I didn't have to do that at all, did I? Let me write this just as is down, and we'll see if you can see it too. X equals negative 5.5 plus or minus the square root of 5.5 squared over 2 times a negative 1/2. Well, that's just negative 1. You see it? Yeah, what's the square root of 5.5 squared? Come on, folks. Square root and the square. Cancel. Sweet. So that just means I have minus 5.5 plus or minus 5.5 divided by 1. I'm going to split this up in my two cases. So I have negative 5.5. Actually, let me clear some space and we'll do this a little bit neater. All right, so I'm going to do it up here. So I've got x equals negative 5.5 plus 5.5 over negative 1. Well, negative 5.5 plus 5.5. Well, folks, that is 0 over negative 1, which is, yeah, it's 0. It's not, does not exist or undefined because I'm allowed to take 0 cookies and split them up into one group. They're just in that one group. So 0, nice and easy. Then I need to take my x value. Oh, that was the one I knew about. Dang, right? This one here, super obvious one. All right, now I'm going to plug in the other one. So x equals negative 5.5 minus 5.5 over negative 1. Well, that's negative 11 divided by negative 1 is 11. That's the one that was more significant. I needed that one. I knew about the 0 because that's where I kicked the ball, right? And the dog starts running because the ball and the dog are at the same spot. But after it's been kicked and it's moving, they're not at the same spot. So let us take that x value and let's plug it in. But I have to erase some of this, so screenshot it if you need it. All right, so I have my 0 and my 11. I knew about the 0 over here, not very significant. I do have the 11 now, so I know I'm over here at 11, but what is my height there? If I don't know the height, I can't find the hypotenuse of that triangle. So let's plug that 11 back in. So y equals, this is plugging into equation 2. So y equals 1/2 times 11, 5.5. Cool, so I know my coordinate point here is 11 and 5.5 right here. So I mean up 5.5. But again, that answers just one of my questions. Horizontally, I've moved 11. Horizontally 11. But how far does the dog need to run? That yellowish, that pumpkin spice slant right there. That's going to be this little triangle, right? I go up 5.5. I go over 11. What is my hypotenuse? So 11 squared plus 5.5 squared equals my hypotenuse, which I use as L. Let me do this, and I'll be back. All right, so the 11 is, of course, 121. And then the 5.5 squared is 30.25, and that equals my length squared. I'm going to add those two things up. 151.25 equals my slant squared. Now I need to take the square root of that, and I'm just going to use a calculator because I ain't square rooting a decimal on my own. All right, and that means my L equals 12.298. So my dog, Xena, she's running, what was it, 12.2, oh, look at that, 12.298, whatever our unit is. We'll say feet for both of these. All right, cool. Not too bad, right? I know you had to go back and look at some of the other stuff if you need to, but I solved the system using substitution in this case. Then of course, with that, I found both of my points. Then I had to go back and read the question. It was very specific, right? How far does the ball travel horizontally? So that was just my x component. Then it said, how far must Xena run? You have to be careful not to put the 5.5 feet straight up. She's not going straight up. She has to run across the hill. So that means she needs the hypotenuse. That's why we had to do Pythagorean theorem. Pythagorean theorem down here. All right, let's go on and let's check out what the other ones have for us. So here, solve a linear quadratic system of equations. Oh, that says inequalities. This one's going to be okay. We do have to graph this one a little bit because it's going to be more of a region. So look at this first one. That is a parabola. The next one is a line, so it's going to be kind of easier. Well, let's do the parabola, but I can't graph it very well like that. I actually need that to be in quadratic, or not quadratic, in vertex form. So if you like to, you can set it to an equals for right now. Just play with it that way, because I know we don't like writing inequalities because we don't do it often. But I can treat them like they're the same as I go through and complete the square to get it into vertex form. So let's see here. Y equals, factor out that -2. And then I have x squared plus 6. Ooh, no, actually it's a -6 because I factored out a -2. X plus a box. And then I have to subtract a -2 times my box, because there's a -2 here. There has to be a -2 here. That's how the boxes go. And then that -10 and -10 right there. Now what goes in my box? Well, that comes from my b value in my parentheses, divided by 2, and then I square it. So 6 divided by 2 is 3. Then I square it, and I get 9. So 9 goes in that box. So then y equals -2, and this is going to factor real nice and easy for me now, right? X minus 3 squared plus, that gets me 18, and then minus 10. Okay, we're almost done. I need to combine my like terms right here. So y equals -2, x minus 3 squared plus 8. Okay, now I can graph this. Now we're doing okay. So let me give myself a little coordinate grid over here. Right, like that. It's pretty close. I need to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, a little much. So 9 and 8. 8 and then 9. And I'm going to the right 3. 1, 2, 3. So I'm here. Then that -2 means I go down -2. So I go down 2 and over 1. So I go down 2 over 1 to each side. And I'm just going to kind of draw a rough parabola here. Then I need to graph my line. Let us use blue. I like blue. I've been going back to this color all day. I need to solve this for y. So I'm going to scooch it over there. 4x plus y is greater than 4. So I'm going to subtract my 4x. Subtract my 4x. So y is greater than -4x plus 4. Oh, and the other one, right? It wasn't equal to. It was y is less than. Let's put this line in here, then I'll start shading stuff. So y is greater than -4x plus 4. So that means I go up to 4. And then from there I go down 4 over 1. Down 4 over 1. So it's roughly like this. Oh, terrible line. Let me try again. All right, there's my line. Close enough now, right? But y is greater than this. So my y coordinate is going to be above my line. So that one, I'm actually shading above my line. But then my other one, my pumpkin spice color, the parabola, I need to extend it actually to down to here. And y was less than that curve, that parabola. So I'm underneath. Oh, I actually went out right here. So let me erase that line again. I'm underneath my parabola here. Okay. So now you'll see the small section where they overlap is the middle chunk above my blue line and below my parabola. So if I have it again, I'm just going to draw another one over here real quick. This is not exactly the same, but it's just to help you see it a little bit better. So and then there's a line. I shaded above this line, and I shaded below the pumpkin spice line. Where do they both overlap? Well, that's what I'm going to do now, double in red. Blue and pumpkin spice are right here. This is my area. Blue and pumpkin spice are right here. This is my area, right here. I'm bounded on top by my parabola, and I'm bounded on bottom by my line. So that is what my graph will look like, okay? So if on a test, maybe I have it labeled region A, B, right there, it's hard to see, and then C, or maybe D over here, it's going to be that chunk in the middle where they both overlap. That's my answer. In there, that's my region for this system of inequalities. Okay, because I shaded both of those. Ooh. Oh, I need to go back to one little step. See how both of them are just straight up less than or greater than? It means technically these are dashed lines. So my bad. I forgot to tell you that. So I have a dashed parabola and a dashed line. And then that's my region right there. Inside of it, but not quite touching my border. Okay. That's it. Hopefully this was helpful. If it was, please click that like button down below. And of course, folks, do your homework carefully and with enthusiasm, and do not do drugs. Have a great day, everybody. Bye.